Hi everyone, so today we're going to start adding and subtracting radicals since last week we worked on simplifying them. So if we think back to just adding and subtracting with variables, if we had 2x plus 3x, we just add the numbers in front, so it would give us 5x. But if we had 2x plus 3y, we couldn't do anything because we can't combine these variables because they're different. So we're going to keep that same thought going into adding and subtracting radicals. So if we have 2 times the square root of 3 plus 3 times the square root of 3, we would just combine. These are kind of like an x, so it just stays the square root of 3. We have 2 of them plus 3 of them, so now we have 5 square roots of 3. So that's your answer. Now if we had 2 times the square root of 5 plus 3 times the square root of 6, we couldn't do anything because they would be like different variables. So another example, if we had 2 times the square root of 5 minus 6 times the square root of 5, these are like the same variables, so we do 2 minus 6 is negative 4 square root of 5. Now you're not always going to have the same number under the square roots, and there is something you can do. So let's say we have 5 times the square root of 3 plus 6 times the square root of 12. 3 and 12 do not match, but before you just say you can't do anything, 12 can be simplified. So it's kind of like the square root of 4 times the square root of 3. So you can simplify it 6 times, you pull out the square root of 4, square root of 3. So we have 12 times the square root of 3. So this is bringing in what we did last class. So we now have 5 times the square root of 3 plus 12 times the square root of 3 equals 17 times the square root of 3, and that's your final answer. So you always look for the biggest perfect square in the number to be able to take out, and then you simplify it as much as you can, and I will give you a hint, all of these problems can be simplified to be added or subtracted. There's none that are no solution. So we're just going to look at another example. Two times the square root of 20 plus 4 times the square root of 45. They definitely don't match, but they can both be simplified. So the biggest perfect square that goes into 20, you can think about, again, what numbers it's between. What perfect squares it's between. So 20 falls between 16 and 25. So you start dividing down. So 20 divided by 16, nope. 20 divided by 9, nope. 20 divided by 4, yes. So it's like 4 times 5. Then 45 falls between 36 and 49, so we start dividing down. 45 divided by 36, nope. 45 divided by 25, nope. 45 divided by 16, no. 45 divided by 9, yes. 9 times 5. So you take out the square root of the perfect square. So we have 2 times 2 square root of 5 plus 4 times 3 square root of 5. So we have 4 times the square root of 5 plus 12 times the square root of 5. Now they match, so 4 plus 12 is 16 times the square root of 5. So you're always trying to simplify down your whatever's under your radical the most you can, and then add or subtract your numbers in front and keep the square root the same. Let us know if you have any questions.